Welcome to Unit 5, Section 2, What Preschoolers Learn. After studying this lesson, you will be able to describe the major areas of concept learning during the preschool years, summarize their efforts to understand logical thinking concepts such as sorting and classifying, ordering by attributes, seeing cause and effect, understanding spatial concepts, understanding number concepts, and noting time concepts. You'll also be able to chart preschoolers' progress in learning word meanings and communicating more effectively, and identify intellectual developmental milestones they might achieve. During the preschool years, brain development and cognitive changes in pretend play, mental images, drawing, language, and memory lead to better comprehension of complex concepts. While pre-operational children do not use logic to solve problems, they are capable of symbolic thought and use their perceptions and intuition to reach solutions. Toward the end of the preschool years, children make advances in several areas of concept learning and begin to lay the foundation for understanding and using logical concepts. They also learn new word meanings and develop more complex grammar skills. In addition to the development of existing concepts, many new concepts emerge during the preschool years. The major areas of beginning concept learning for preschoolers include noting physical attributes, understanding physical knowledge, using logical thinking concepts like sorting, classifying, ordering by attributes, seeing cause and effect, understanding spatial relationships, understanding number concepts, and noting time concepts. From the moment they are born, children use their senses to develop concepts about size, shape, color, texture, and other physical attributes or concrete qualities that can be sensed of objects. During the preschool years, their sensory organs mature and their senses become more coordinated. As a result, children's abilities to make sense of their environments improve during the preschool years. Preschoolers focus on some physical attributes more than others. For example, 3 and 4-year-olds may pay attention to the color and size, and 5-year-olds primarily note the shape. Due to concentration, they are limited in their abilities to comprehend a variety of physical attributes at the same time. Therefore, they center or focus on the attribute that stands out to them. Preschoolers who are learning to note physical attributes may make mistakes. While they may note many features, they may not note the object's most important features. For example, they may notice a zebra's ears but not its stripes, which are the most important in distinguishing a zebra from a horse. Because they tend to focus on individual attributes, they do not always mentally see the whole object. When they are shown drawings, like of 2 apples and then a comma and a banana that looks like a face, they tend to recognize the parts of it, like, oh, those are apples, that's a comma, that's a banana, but not that it's like a smiley face when it's all put together. Starting at 4 months of age, they begin learning what happens when objects are acted upon by people or other objects. These are lessons of physical knowledge, which is the knowledge acquired through observations of your physical world, like attributes of object, aka their color and shape, and observable phenomenon, like how gravity works and comparative speed of balls rolled on flat surfaces and inclines. Many physical knowledge concepts, including natural events like evaporation and thunder, are too complex for them to understand. They lack the logic needed to understand these concepts, so they settle on their own ideas about how the physical world works. Some of these illogical ideas include the following. Animism, which is the attribute of living qualities to inanimate objects. Preschoolers may assign human qualities to non-human objects, such as plants, animals, and possessions. For example, a preschooler who falls off a bike may say, "The bike was mad at me and made me fall." Sometimes they use animism to avoid being punished or having to do something they don't want to do. Artificialism. Preschoolers may believe that everything is made by a real or imaginary person. For example, a preschooler may say the sun was rolled into a ball by giants. And finalism. They may see everything as having an identifiable and understandable purpose. For example, they may say the ball rolled away, so I would have to chase it. Teaching physical knowledge concepts by telling them about the world around them is difficult and not effective. Preschool children learn physical knowledge best through experimentation. Therefore, they need to be given opportunities to experiment with objects and events that they can observe. From an early age, children participate in problem solving. Problem solving is a broad term that most often includes noting a problem, observing and questioning what is observed, and solving the problem. By the preschool years, children use both physical, or trial and error, and intellectual, intuition, problem-solving skills. Intellectual problem solving depends on children's understanding of logical thinking concepts. Logical thinking concepts are those not directly experienced through the senses, but are developed through thought, such as noting similarities and differences in objects and coordinating symbol relationships, like classifying, ordering by attribute, and counting. While these concepts cannot be physically observed, they can be seen in the mind. As the name suggests, these concepts will not fully develop until children are able to think logically. As a result, their abilities to use these logical thinking concepts are immature. Logical thinking concepts that begin to develop during the preschool years include sorting and classifying objects, ordering by attributes, seeing cause and effect, understanding spatial concepts, understanding number concepts, and noting time concepts. For sorting and classifying objects, during the preschool years, children's abilities to sort improve. Their sorting techniques differ from adults, though. For example, a preschooler might sort a boat, a paper plate, and artificial flowers into a group because these were involved in a recent picnic. If sorting by shape, they often make a graphic collection of shapes that looks like a picture. Around 4 years of age, they develop the executive functions needed to change their sorting criteria. Their cognitive flexibility lets them change sorting rules, such as sorting by circles and then by squares. Working memory helps them remember sorting rules. Inhibitory control keeps them focused on sorting criteria, even if they would like to sort another way. Many older preschoolers sort by attributes, such as color, shape, size, material, patterns, and functions. Preschoolers also learn how to classify. Classify involves choosing an attribute, selecting all 8 objects that contain the given attribute, which we call the class, and then recognizing objects that do not contain it, which we call class complement. Classifying is more difficult than sorting. This is because sorting involves paying attention to a variety of attributes, whereas classifying involves focusing on one chosen attribute while considering all others as not belonging to the class. Classifying is not usually mastered until children are school age. During the preschool years, children also begin to learn how to seriate. Seriation is arranging objects in order by increasing or decreasing magnitude of one of the object's attributes. Could be length, could be the shade of a color, could be a texture or pitch. Preschool children can easily identify extremes in most attributes, such as the largest and smallest square. Because noting extremes is an easy skill, young preschoolers just alternate between large and small objects rather than truly seriating them. Seriating 3 or more objects is more difficult than finding 2 extremes in an attribute because it requires a two-way simultaneous mental comparison of an object's attribute, like the size or length, to the same attribute in other objects. For example, when a person is ordering on a decreasing or descending magnitude, an object placed next must be less in that magnitude than all the preceding objects and more in magnitude than all the other objects. If ordering an increasing or ascending magnitude, the reverse would be true for that. Toward the end of the preschool years, children's seriating skills improve. Many older preschoolers are successful because they use their perceptions to physically manipulate the objects. For example, they can arrange dowel rods and sticks in order of their lengths, but to do this, they must physically lay the rods beside one another and align all of the bottom ends evenly. To seriate other attributes, they must physically place the objects next to each other, arranging and rearranging them. In contrast, older children can seriate by just pointing to the order without actually moving the objects. Because preschool children are not logical thinkers, they have difficulty seeing cause and effect, especially when cause and effect relationship is not directly observable. As a result, they tend to create their own explanation of events. While preschoolers have difficulty with unobservable cause and effect relationships, studies show that they can understand many visual displays of cause and effect. They may still have problems with the complex sentence structure of cause and effect language, and may reverse cause and effect when speaking. Unobservable and difficult cause and effect relationships are often misunderstood until the teen years. While preschoolers understand the words that indicate spatial relationships, they still have trouble comprehending spatial concepts. They think about spatial relationships in reference to themselves. While they understand what is on their right and left, knowing right and left from another person's perspective or in a spatial relationship to an object is a lot harder for them. So if you say, go find a toy to the left of the couch, they won't know. Preschoolers tend to draw what they think about a space rather than what they actually see. As early as toddlerhood, children have some spatial memory, usually in the form of mental maps. Mental maps are remembered mental constructions seen in the mind's eye that organize spatial relationships from an individual's perspective. A mental map enables a person to navigate his or her own house or other familiar places without thinking and envision these places without being physically present. While these mental maps are far from perfect in the preschool years, preschool children exhibit some understanding of mental mapping, especially if mapping in a 3-dimensional form. For example, mapping in 3D means making a mental image of spatial arrangements after seeing a furniture arrangement in 3 dimensions in a real house or in a model of a house, like a dollhouse. Conversely, two-dimensional mapping, which preschoolers cannot typically do, means forming mental maps using two-dimensional images, such as maps or floor plans, and being able to envision these spatial relationships when they're not looking at the image. Understanding number concepts. From a young age, they have a basic comprehension of quantity. Many older toddlers and young preschoolers show counting-like behaviors or can say counting words. However, this type of counting does not mean that they understand numbers. For example, a preschool child may be able to count to 5 by saying the numbers, which we call rote counting, but they may have trouble when asked to find 5 apples in a basket. During the preschool years, children's comprehension of number concepts increases dramatically due to their brain development. The left parietal lobe is being wired for understanding numbers and their functions, and synaptic communication across many parts of the brain is needed for math success. For example, memory areas are needed for remembering rules and recognizing patterns. Language are used for understanding vocab and rules, and spatial visual processing is essential for recognizing math symbols. Number concepts require several complex understandings. Even before the preschool stage, many children understand the concept of more. Young preschoolers can imitate the counting-like behaviors of adults. Adults are often misled about their understanding of counting. Although many preschoolers can rote count, young preschoolers seldom understand the one-to-one relationship that takes place when counting objects, which we call rational counting. Even when watching older children or adults count while touching objects, they do not understand that one and only one number can be assigned to each object and that they must all be touched once and only once. Although they go through the counting motions, they will often miss some objects or count other objects twice. Number concepts at 3 years of age. 3-year-olds can handle one-to-one correspondence for groups of up to 3. When shown 2 rows of 4 or more objects with a physical one-to-one correspondence, they can identify that they are the same. However, if one row is slightly spread out or compressed, and even if another object is added to a compressed row, these perception children use the endpoints to determine which row has more. At 4 and 5, children's comprehension of number concepts leaps forward. Math understandings are logical concepts, not physical ones. 4-year-olds who can count will use counting to determine equivalence or non-equivalence of 2 rows and can use the one-to-one principle. Until about 5 years, numerosity, or numerousness, is a difficult concept for preschoolers to comprehend. It's difficult because, unlike names, which refer to one object, a number does not refer just to the last object named, but also an entire group of objects. Therefore, a child must mentally see what the number is, the number 1 within the number 2, and that 2 is within 3. By 5 years of age, many preschoolers can add and subtract concrete objects. If they know the number sequence, they can make mental comparisons like 4 is more than 3. Older preschoolers can plot numerals on a number line, but the spaces between consecutive numbers will not be kept equal. In effect, forward counting by ones is adding increments of 1, and backward counting is subtracting in increments of 1. Counting forward is also seriating in ascending order, and counting backwards is seriating in descending order. Lastly, noting time concepts. Improvements in working memory during the preschool years help children recall the recent past. They may still struggle with long-term memory. They may remember an event that happened yesterday, but forget events that occurred a week or a year ago. They link time with events that occur at specific times, like home routines or regular activities in a preschool program schedule. They do not see time passing because daily and seasonal changes are very gradual and no physical changes occur between the days of the week, like the sky isn't blue on Tuesdays and purple on Wednesdays. For these reasons, time concepts are very difficult for preschoolers to understand. Older preschoolers may be introduced to calendars and may learn the names of the seasons, the months of the year, and the days of the week. But most of these are rote memorization or learning by repetition and don't have meaning behind them. Time concepts is one of the last concepts to develop in childhood. During the preschool years, language and communication abilities continue to improve. Preschoolers are better able to articulate and are rapidly learning the vocab and grammar they will need to communicate their needs and feelings effectively. Their egocentrism impacts their speaking in that their language reflects their exact thinking. They use egocentric speech, which means that they talk as though the listener will understand what they are trying to communicate in the same way as they do. Thus, they often do not communicate all the needed information. Examples of preschoolers' egocentric speech include telling a story from the middle instead of the beginning, and using pronouns without naming the pronoun's object. Egocentric speech also includes repeating words without speaking to anyone. Sometimes children speak in monologue by talking to themselves as though they are thinking out loud. Other times they engage in collective monologue by talking to another person but not listening to what the other person is saying. All children will go through this stage of language development. Toward the end of the preschool years, egocentric speech gradually disappears and makes communication easier. Communication also becomes easier as they are learning articulation, expanding their vocabularies, and learning grammar. In the English language, children are able to articulate words fluently and coherently between 3 and 8 years of age. Although the timing in which they master the sounds of the language varies, the order in which they master these sounds is about the same for most children. Children achieve total mastery when they can articulate sounds in different positions within words. Typically, children will master the sounds M, N, P, H, and W by 3 years of age, examples being monkey, penny, pig, hand, window, nails. By 4 years, they'll do B, K, G, and F, so boat, baby, tub, cat, chicken, book, girl, wagon, pig, fork, telephone, knife. And then by 5 years, the last sounds to develop are Y, ng, and D. So yellow, onion, fingers, ring, dog, ladder, bed. Children continue to expand their vocabulary as they learn words and their meanings during the preschool years. At 3 years of age, they know about 900 words in the English language. By 4, they know 1,500, and by 5, they know about 2,000. Children tend to learn the words and names for concrete items like objects and people before they learn those that symbolize abstract ideas such as emotions. Preschool children often assign their own meanings to words. The window of opportunity for vocabulary growth never closes, so vocabulary continues to grow and develop far beyond the preschool years. Brain development research shows the window of opportunity for learning grammar through listening closes at 5 or 6 years of age. Because of this, grammar development is critical during preschool years and becomes more difficult once children are school age. During the preschool years, children begin to use more complex sentence structures and comprehend correct word order. Children's grammar matures dramatically between 3 and 5 years of age. Grammar at 3 years, 3-year-olds can begin to understand some grammar rules, like adding ing to the end of a regular verb for present continuous tense, like roll, rolling, adding ed to the end of a regular verb for past tense, like roll, rolled, changing some irregular verbs for simple present tense to simple past tense, like sink, sank, using a linking verb is am to link a noun to an adjective, like the truck is red, adding s to make a plural, like car to cars, adding apostrophe s to form possessive, like Bob's book, using an article, like a or the, to precede or modify a noun, like the library, a toy, and using a preposition referring to space, on or in, like on the table or in the room. Once they learn these rules, they tend to apply them to sentences and words, including those that are exceptions to the rules. 3-year-old preschoolers may know that ed indicates past tense, but once they know this, they may apply it to all verb forms. Over time, preschoolers will learn the exceptions to these rules. Young preschoolers do not always comprehend word order. They will use incorrect word order at times and correct word order at other times. They may also have a difficult time with questions because of how word order is switched. 3-year-olds may use question words such as when and why, but have not mastered the switched order of the noun and verb used for questions. The typical noun and verb order for declarative sentence is switched in an interrogative sentence to a verb then noun order. For example, where is the book? And the book is here. Okay, the book came first in the book is here in the declarative sentence, whereas in the interrogative, where's the word book came at the end. And they have trouble with that. Negative words are also very difficult for young preschoolers. Once they know about negatives other than no, they may use double or multiple negatives in sentences. For example, sentences like, I don't never want no more spinach, are common at this age. 4 and 5-year-old children will begin to speak in longer, more complex sentences. They can lengthen sentences by using clauses, conjunctions, and prepositions. Instead of saying, "We play games, I had fun," an older preschooler may say, "I had fun because we played games." 4-year-old children may still find word order in questions confusing. They may form questions by moving the question word to the beginning of the statement, such as, "What is the dog eating?" 5-year-old children begin using tag questions, which are formed by making a statement and then adding yes or no to ask the question. An example of a tag question is, "The baby is small, yes?" By 5 years of age, however, children are able to identify and use correct word order more consistently. Although older preschool children use correct order more consistently and have made large advances in grammar, they continue to have two problems with grammar. One problem is using the correct case for pronouns. Older preschoolers often use objective case pronouns when they should use subjective case. For an example, an older preschooler may say, "Him and me went to town," instead of "he and I went to town." The second problem older preschoolers have with grammar is they continue to apply some grammar rules too widely. They may say "eated" instead of "ate." Once they learn irregular forms, they may even say "aided." A 5-year-old may learn to use plural form of feet and ask, "May I go barefooted?" The many irregular forms in the English language will trouble some children for years, even if they hear and make strides in using correct grammar. Concepts and abilities that develop during the infant and toddler years continue to mature in preschool years. Although they are not yet capable of logical thinking, they use both their perception and intuition for solving problems that lay the foundation for logical thinking. The preschool years are critical times for learning vocabulary and grammar. So some of the milestones that we will go over: when can children rationally count to 10 or more objects? Not till 5 years old. When can they solve some problems correctly through intuition? 4. At what age do they give illogical reasons for events? 3. All right, thank you guys for listening. That is the end of this section.